Hey guys, I'm glad that you're back and watching this video. This will be the video that I will be using to show you how to answer the question 4 in your portfolio. And here's what question 4 looks like. You have two equations. So you have another system of equations when we have two of them. It's the first time we're going to really experience the system of equations that I explained in the last video. But you're going to have a different problem you're going to be working on with me. Now, you see a system of equations, and it says show your work to find the solution. You may use the coordinate plane to help you. I'll get into this graph later. First, I want to show you what we can do to solve this algebraically. You see two different equations, x plus y equals 12 and x minus y equals 4. And we don't really know how we could answer these. Like, what do you mean by find a solution? What I mean is, I need a coordinate pair. A solution for a system of equations is going to be written x comma y, which is how you write an ordered pair or coordinates that go on a graph. It also is the same variables that you see over here. We have an x and a y and another x and a y. And I need to figure out what x is and what y is for both of these equations. They're in the same system, so they need to have the same y and the same x. All right. But what could we do? Well, if we knew what one of these variables were, we would be able to solve it easier. But I'm going to show you what we could actually do when we have something like this. So scroll back up. And when I asked you earlier to write down or fill in these blanks, I did it for a reason. We used this elimination process to figure out these, but we need to now use it differently. So you need to have, again, the same number, the same variable, and different signs. So I look over here and I wonder, is there a way that I can eliminate using these two equations? So when it's written like this, it might be hard to see, but maybe I'll write it like this. Have that x there, minus y equals, equals 4. So let us look at what I just wrote and compare the two equations for a second. I'll pause as well. So just compare these two equations. I'll even erase this one for now. And tell me, is there a way that I can use math to eliminate a number or a variable? And remember, the goal is always to have one variable, x or y, alone on one side. So when I wrote it like this, I noticed something. I noticed that if I went up and down and just combined all my terms, I would get a pretty clear number. So let me just do this so it's easier. So if I went up and down, I'm just playing around with some math, and I have x and x here. This is a positive x, and this is a positive x. So if I combine two positive x's, I will have two x's. And here's where the elimination takes place. So here I have a positive y, and remember, if there's no number in front of a variable, we could assume that it's 1. So I have a positive 1y and then a negative 1y. And when I have the same number, the same variable, but different signs, I could eliminate, which means I can get rid of it. So I can get rid of the y. 1 minus 1 is 0. So the only thing that needs to drop down next is the equal sign. We combine our 12 and our 4, both are positive, equals 16. Now we're cooking with butter because we know that 2 times x is equal to 16, which then means that we could divide by 2 on both sides. So divide by 2 on both sides of the equal sign, ladies and gentlemen. Because the opposite of multiplication is division. So if 2 times x, that's multiplication, we need to then divide by 2 to get x alone. We need to remove 2 from this side. Divide by 2 on both sides of the equal sign. Oh. And we're going to be left with 2 divided by 2 is 1. So you could either put 1x, or I just simply put x. There's no need to put the 1. My equal sign drops down. 16 divided by 2 is 8. You could double check me on the calculator. And yeah, we know what x is now. Great. But how does this help us? How does knowing what x is help us figure out what y is? So we eliminated the 1y or the y because we had a positive 1y and a negative 1y. And that helped us to find what x is if we follow the steps. Now, the reason why x is so important is we can now take either of these two equations. And I'm going to take this one up top because it's the first one I see. And we could now substitute. So this is elimination. And now we're going to work with substitution. It's okay to formatting that the graph went to the next page. Oh, it doesn't even go to the next page. Let's see. There we go. So if that happens and this graph disappears and it doesn't show up here, you just need to hit a backspace a couple times and make it appear on this page. I'll try and do my best formatting to make sure that it does not disappear. But we'll do that later. Because we're substituting now. So when we substitute, we take this number that we got for x, because we don't need to put x anymore, and we substitute it in. So instead of x plus y equals 12, it's 8. And I'll put that in parentheses so you know. It's 8 plus y equals 12. Now we could solve this. So if we need to know what 8 plus y equals 12 is, we do the rules. Follow the steps. Y is what I need to find. I'm looking for the value of y. I need to have y alone on one side, just like x is here. So we take our 8 and we need to eliminate it from this side. So the way that we eliminate a positive 8 is to minus 8. And we do that on each side of the equal sign. If you don't do it on both sides, we will not get the right answer. 8 minus 8, sorry. 8 minus 8 is going to be 0, so we don't have to put anything. Our y drops down. Our equal sign definitely drops down. And 12 minus 8 is equal to 4. So y is equal to 4. Oh, and there you go. Fantastic and quick and easy. Thigh peanut chicken just popped up. Sweet. So, if y is equal to 4 and x, oh, looks like we're getting a chicken recipe popping up again. All recipes. I'll handle you later. Oh, again, sorry. Y is equal to 4, x is equal to 8. So when you write down the answer or solution, the answer would be x is 8, y is 4. All right. Now that's how you solve it algebraically. But you could also solve it using a graph. Now for this portfolio, you do not have to do both. So why am I saying that? Well, if you read the question, it says Find the solution of the following systems of equations. And you did that here. Show your work. So before I go into how we could use this graph, I'm gonna show you what I mean by show your work. Because I got my solution. I did that already. It seems like I'm done. I'm not. Check your work, ladies and gentlemen. What I mean by that is substitute x and y together and see if these are true. So if x is 8, we're going to write 8 plus 4. And I write 4 because my y is 4. So I could replace x with 8, and I replace y with 4, and 8 plus 4 is equal to 12. That is correct. So I know that for this equation, 8 and 4 works. Let's see if it works for this equation. My x is 8. And my y is 4. So it's going to be minus 4 is equal to 4. So if 8 minus 4 equals 4, then both of these check out. This is the solution. This is how you could show your work. All right. And this is something you could use to help you graph it. I don't recommend actually using the graphing method unless you're familiar with how to graph an equation not in y-intercept form, or you know how to make it into y-intercept form. So let me just show you. But first, if you're using Google Classroom and I give you this graph, if you try to move it, these dots, this whole picture is just going to move. You see? So don't do that. If you do that by accident, you could hit Control and then Z, and that will undo your last thing. So I need you to watch what I do. It's on the page. You click it, and this should get highlighted by a blue square. And then you click the Edit button on the bottom. And this is on a laptop, so I don't know what it looks like on an iPad. And you'll see a drawing. On the drawing, you will be able to move these dots. So you see one just moved. My computer is a little slow. But here are the rules. You cannot have the dot highlighted before you move it. So you see how it's not highlighted here? Now I click and hold it. I hold the click. And while holding that click, I'm dragging the dot. You see how it's being dragged? And let's say I wanted to plot it on the origin, or 0, 0. I would drag it about here. Now, I know it's not perfect, and it's not the easiest thing in the world to work, but if I see that you are graphing it with relative accuracy, so if it's in the middle a little bit, I don't mind. As long as you show me that you know what you're graphing, I'll be cool with it. So if you graph these two equations, I'm going to close this for a second. You need to figure out what the equations are in slope-intercept form. So I'm going to erase this work. Oh, you see? What I just did was I accidentally clicked the wrong spot and the graph moved. So if this happens and you don't know the key binding, you go to Edit, and if you press this undo, it'll go back. So I'm going to erase this work. Don't worry, if you go back in the video, it's still there. I'm going to erase all of this, and I'm going to be left with these two equations again. So how do you take these two equations and make them graphable, y we say you need to turn it into slope-intercept form, y-intercept form, and the way you do that is you need to have something that mimics this equation. So you need to have y alone on the left side of the equal sign, and it's got to be equal to something or a number times x. We'll just put 1x or x, mx. That's what mathematicians like to use. So a number, m, times x, which is the variable, and I'll put it in parentheses for you to make it easier. So m times x plus b, and b is the y-intercept, and m is the slope, right? So you need to take this equation and make it look like this, y equals mx plus b. So you know that the y needs to be alone on one side. So I'll put these like this now, and let's see. So to get y alone on the left side, I know I need to get rid of x. So what I do here is I minus x on both sides. Because again, we're still using this inverse rule. So minus x on both sides. So x minus x is 0. So my y could just be left alone. Y equals. Now, 12 minus x. You can't actually add or subtract x from 12. You can't take a number and subtract a letter. We don't know the value of x. We do, but we don't know it yet when we're doing it like this. So y equals, well, look at what I want the format to look like. It needs to be a number times x. In this case, is there a number in front of x? Well, it would be 1. So if you want to write equals, you just take your x value and the number attached to it. So here would be negative 1x, because you want to put it in the same spot. So you minus x on both sides. These two cancel out. My y drops down. My equal sign drops down. And I need to take these two integers and put them down here and rewrite them like a sentence. So the reason I put my negative 1x first is because here it says y equals a number or the slope times x. Here's a number times x. And then plus b, or plus the y-intercept, is going to be plus 12. Same thing here. I need to get my y on one side. So I'm going to also do minus x here. Minus x. And we're going to take this x minus this x. So we're left with, negative y. And I don't need to put that 1, but I do need to put the negative sign. So negative y is equal to, and again, we have this negative x here. So in our y equals mx plus b format, we need to have the number in the x first. So negative x plus 4. Now you might think this is good because it matches this format. Y equals mx. Here's x. The m would be the 1 in front of it. Plus b. But does it say negative y equals mx plus b? It doesn't. So you can't have a negative y here. How do you remedy this, or how do you fix this? Well, to get a negative number and make it a positive, we use division. So when you divide, you got to divide every number in the equation. Every integer, I should say. So you're tasked with turning this negative y into a positive y. But what would we have to divide negative y by to make it a positive y. Well, I still need it to say y, which means I can't divide it by a number that's going to either increase or decrease it. So when I want to divide by a number that does not change the value but will change the sign, I divide by 1. Now whether it's positive or negative is determined by the sign above. So if this negative y is negative and I'm looking to make it positive, I know that if I divide a negative number by another negative number, it would make it a positive. So my negative y divided by negative 1, my y times 1 will be y, right? 1 times 1 is 1, or 1, sorry, divided by 1. But the negative sign in these two cases will turn the answer into a positive. So I'm going to be left with positive y. So again, if we have negative y, and we put that 1 there to make it more apparent to you, so negative 1 divided by negative 1 is going to be positive 1, and then my y drops down. But in math, we don't need to actually show the 1 in front of the variable, so we could just leave it as y. But for the rest of these, we also need to divide it by negative 1. So negative 1x divided by negative 1 is going to equal positive x. And then positive 4 divided by negative 1 is going to equal negative 4. So what this just accomplished is we turned these two equations into equations right here. Here's 1, here's 2, that we can graph. So I want you to remember these. We have y equals negative 1x plus 12. So we got to go to our graph, and we got to edit again. All right. So I want to be able to show you guys the equation as well while I do this. So here's what I'll do. All right. So again, to get to the graph, you click on it, just single click, and then this blue square will appear. You hit this edit button. So we have this graph, and now we need to graph two lines. So each equation, y equals negative 1x plus 12 and y equals x minus 4, both of these can be graphed, and both of these equations will have its own line. So when I graph them, I will show you how to figure out the solution for these two equations. So if I have negative 1x plus 12, the way I graph that is by looking at the y-intercept first. On the sheet, I indicated that the y-intercept can be found here, where b would be. So if it's y equals mx plus b, oh, what did I do? Sorry. Let me do this. Sorry, a little formatting error. But we have y equals mx plus b. Mx plus b, sorry, finally. The b represents the y-intercept. The y-intercept is the place on the graph where the line goes through the y-axis. So if the y-intercept is 12 plus 12, I need to look at my graph, find where plus 12 is. So if plus 12 is all the way up, so here's the y-axis, it goes up and down. We go from 0, up 1, up 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we had to go up twice more, it would be at 12. So I understand that this graph's not big enough for the 12 to be on the y-intercept, but that's okay because we could still pretend like 12 is there. So just for the sake of pretending, let's pretend that there's a line that up here would be 11, where my cursor is. And if we go up here, that's 12. So we're going to take this dot, and I'm going to put it on the y-axis where 12 would be. Okay? That's the first coordinate, the y-intercept. Now I need to figure out, using the slope, m, how to move along the graph using this line. So if my y-intercept is 12, and my slope, which is where m is -1, then that tells me the slope is negative. So my line is going to be going this way, down, right? Negative slopes go like this, where my cursor is going. Do it one more time. So the slope is negative, and it's -1. A -1 slope, and if we use rise over run to explain this, so it's going to be rise equals -1, and the run is going to equal 1. Because if the slope is not in a fraction, we need to make it a fraction. And the way that you make any number a fraction, so if this is -1, the way that I make -1 a fraction is simply by putting it over +1, and I'm going to write that as a fraction. So any number on the number line, you can make into a fraction by putting +1 as the denominator. So you put this number as the numerator, and it's -1, and on the bottom, it would be +1, because any number could be made into a fraction by putting 1 underneath. But how do we use this? Well, a rise is basically your way of going up or down. If it's positive, you go up, and if it's negative, you go down. And the run is left or right, right? But usually, we want to just go to the right. So you need to go up or down, and then to the left, sorry, or the right. So the rise here is -1. You know that on a graph, you want to go down when the number is negative. And the run is also 1, but this one's positive. So when it's positive, you know that on a number line, you're going to the right. So negative on the up and down scale means we would be going down. And 1, when it's positive, means we go to the right. So let's actually apply this rise over run thing. So if the rise is -1, meaning we go down 1, and the run is 1, which means we go to the right once, let's see it in action. So I'm going to use this dot. So if we're here and the rise is -1, we need to go down 1 point. And remember, I know 11's not there, but we're going to pretend it is. So we go down 1, and then we need to go to the right 1 time as well. And that's my next point. And we keep doing that. So here, down 1, over 1. We keep doing that. Again, down 1, to the right once, until we have a bunch of coordinates. And just keep doing it. Mr. C, you're dragging it, but like, look, this whole problem's about dragging dots, so you are darn skippy that I am dragging it. And I know it's tedious, and you guys on your iPads are gonna be not liking me. All right, so look, a line. And then when we're done, look, there's even a section that says line, and we could now connect our dots. That was a horrible line. So I'm going to press Control Z, or Control Z undoes it. See? Undo, Control plus Z, or you could just click this button. I'm going to click this line one more time. I'm going to click the line this time, and I'm going to draw one connecting these dots. And that's all right with me. except, sorry, the line that we want to use is the one with the arrows. So last time I drew the line. And there we go. We have our line for the equation y equals negative 1x plus 12. So that's one of the equations. Here's the second one. Y equals x minus 4. So again, we want a rise over a run. This is slope stuff, guys. The rise would be your x value. So here, x is 1 or positive 1 because here it's positive x and we know that 1's in front of it. So my rise is going to be positive 1. And remember, this is up slash down. And my run is now going to be this number with a 1 underneath as the denominator. So if the number again is whole, like this is a whole number 1, it is not in a fraction, we need to make it a fraction. And we do that by putting a 1 here, because that's the value for x, that's m, and then a 1 on the bottom as the denominator, because we needed to make it a fraction. To graph this, using rise over run, the first step is to take the y-intercept and graph it. So my y-intercept can be found where B is located. And in this example, it's negative 4. If you forget this negative sign, your line will not look correct. So you need to graph now negative 4. So we count from 0, and on the x-axis, we graph on the y-axis, we graph the value negative 4 on the line, because that's the intercept. So we go down from 0, we go down 1, 2, 3, and 4. And our slope, our rise over run, is 1 over 1. Positive 1 tells us to go up. So, same process as before. We take one of our dots, put it on this. We go up 1, because that's the rise, and then over 1 to the right, because that's also positive. Both numbers are positive, which means we go up 1 to the right 1. And let's keep doing that. I hope we have enough dots. I'm sure we will. If not, I'll make more. Oh, look at that dot. That dot's not in a good spot. Better. All right, just keep doing them. Just keep putting the dot till something happens. Nothing's happened yet. We're just drawing our line, putting our dots down. Dot. More dots. Oh, oh look. We have some overlapping dots. I wonder what that means. Let's just finish our line. Draw our line up here. Select the line. We want the arrow. Let's draw a line through these. All right. Voila. Look what we got. We got one line going this way, one line going that way. They are graphed correctly. And they intersect, which means they pass the same point right here. So what happens, I'm going to paint this red. What happens at the red dot? Both lines cross each other. Both lines go through the same point. And the point that our lines go through, well, if we had to write them in coordinates, we know it's x comma y. So the x value for this coordinate, let's see. If we start at 0, go to the right. 1, 2, 3, 4, 5, 6, 7, and 8. So our x value is apparently going to be 8. And our y value, let's see. We go up from this 8. Up 1, up 2, up 3, and up 4. We have 8 comma 4. So I'm going to see if this makes sense. So rewind this video, or I'll solve it for you real quick again because it erased. So if x is 8 and y is 4, let's plug them in. So we have x plus y equals 12. So 8 plus 4, this is the check, equals 12. X plus y equals 12. 8 plus 4 equals 12 checks out. And for this one, we have x minus y equals 4. X is 8 minus 4, which is y, equals 4. That also checks out. It is the same answer as we got before. So regardless of which method you use, you will be able to figure this question out. But I would definitely recommend, if you have trouble or if you're not used to converting these equations into y-intercept form, to just use the elimination steps that we used here. So if we have a positive y and then a negative y, and they have the same number and same variable like this, we could just use this process of elimination and then substitute later to figure out the value of y and figure out the value of x. I know this was a lot, and I could have probably made this video a little clearer and shorter, but I think there was a lot to go through for this problem, depending on everybody's on a different level. So I want to make sure I go through everything possible. So this was the practice for question 4. You could either do it using these steps that I used here, or you could use these steps to convert each of these equations into y-intercept form, which is in the form y equals mx plus b. Don't forget that when you use your slope, the number that represents m, it must be in fraction form. So you just take that number and put it over 1, and you will have your fraction that will help you go through the graph. The top number tells you to go either up or down. We say this is the rise. And the bottom number tells you how many times to go to the right, or if it's negative, to the left. So, hope this helped. I'll be back with the next video shortly.